BIOS setup. The BIOS, Basic Input-Output System, is a chip located on all motherboards. It contains instructions and setup for how the system should boot and how it operates. The BIOS includes instructions on how to load basic computer hardware and includes a test referred to as a POST, Power On Self-Test, that helps to verify that the computer meets its requirements to boot up properly. If the computer does not pass the POST, it indicates by a combination of beep sound. The four main functions of BIOS. POST, P-O-S-T. Test the computer hardware and make sure that no errors exist before loading the operating system. Bootstrap Loader. Locate the operating system. If a capable operating system is located, the BIOS will pass control to it. BIOS Drivers. Low-level drivers that give the computer basic operational control over your computer's hardware. BIOS or CMOS setup. Configuration program that allows you to configure hardware settings, including system settings such as computer passwords, time, and date. Boot sectors. All disks and hard drives are divided into small sectors. The first sector is called the boot sector and contains the master boot record (MBR). The MBR contains the information concerning the location of partitions on the drive and reading of the bootable operating system partition. During the boot up sequence on a DOS-based PC, the BIOS searches for certain system files, io.sys and ms.sys. When those files have been located, the BIOS then searches for the first sector on that disk or drive that loads the required master boot information into memory. The BIOS passes control to a program in the MBR, which in turn loads io.sys. This latter file is responsible for loading remaining of operating systems. There are two kinds of boot sectors: volume boot records and master boot records. Boot sector is responsible for the further boot process of the system. It has length of 512 bytes. The first 446 bytes are the primary boot loader. This is also referred as PBL. The next 64 bytes are the partition table. It has the record for each of the partitions. The MBR ends with 2 bytes. That should be 0 into AA55. These numbers act as validation. Tasks of boot sectors. Boot sectors check the operating system and hardware components are working properly. It will ensure a computer to successfully boot and its BIOS. Sometimes failure occurs among any of these components. Then it will likely to result in a failed boot sequence. Boot image. An exact bit-for-bit copy of a computer's operating system as it exists in memory immediately after the initial boot operation. Such an image may not be identical to the operating system executable file stored on disk, as it will probably have had various drivers and other configuration options applied during the boot up. Boot images are sometimes stored on disk to speed up a lengthy startup process. Boot sector virus. A boot sector virus is one that infects the boot sector of a floppy disk or hard drive. Boot sector viruses can also infect the MBR. The first PC virus was Brain, a boot sector virus that exhibited stealth techniques to avoid detection. Brain also changed the volume label of the disk drive. Steps in booting process. Loading and initialization of the kernel. Device detection and configuration. Creation of spontaneous system processes. Operator intervention, single user boot only. Execution of system startup scripts. Multi-user operation. Loading and initialization of the kernel. Kernel, example program, is loaded into memory to be executed. Path name of kernel is vendor dependent, for example, /Unix or /VM Unix. Second stage loading process. First, small boot program read into memory. Second, kernel runs and tests to determine memory availability. Device detection and configuration. Kernel performs hardware check. General hardware device info is incorporated in kernel configuration. Locate and initialize each device. Acquire more info via driver. If not found, it will disable the hardware. If hardware is added, we must reboot to access. Creation of spontaneous system processes. After basic initialization, kernel creates spontaneous processes in user space, not created via normal Unix fork mechanism. Fork creates copy of the original process with new ID that is identical to the parent.